Greetings, I'm Brian from RC Workboat Haven. Welcome to part 2 of the 1898 supply steamer build. In part 2, I'm going to show and describe the exterior work done on the hull, the interior work that brings the model up to a ready-to-run stage, and we're going to do a complete disassembly of the components. At the end of the video, I'm going to go into some detail about electronics. I've got a lot of material here to cover, so let's get busy. Thanks for watching. Now, my first step when I'm starting off with a new fiberglass hull is to sand the gel coat, which is extremely glossy, with 80 grit sandpaper. And I did that on this model and on my other gaff cutter and bad weather ship builds. So that's step number 1. In part 1, you will notice that I had already fixed this stem onto the bow. And this is to give it a roughly an 1890s old-fashioned look. I did that right after I had sanded the gel coat because I like to put the epoxy directly from wood onto gel coat. So I fixed that on and that was secure. So after the hull was sanded with 80 grit, I gave it 2 coats of latex primer sealer. And that stuff, once it's dry, really bonds onto that sanded gel coat. So now with the latex, I can use wood glue to attach pieces onto this hull. My standard fiberglass hull has a gunnel that's molded right into the fiberglass, and it forms a half round. To get the right look on this steamer build, I wanted to expand that gunnel with a large wooden piece. So in order to mount this outer section here, I had to somehow give it something to glue to. So out of basswood, I cut some strips, 3/32 of an inch square, and I glued those onto the upper side and the lower side of that half round shaped gunnel. Now, the method I used to clamp these small strips was to use a little clamp, a straight piece of wood, and a little backer block like this. And this backer block would hold down the lower piece and the upper piece. And then when I did the larger covering piece here, I would just lay this on the side and make sure I had nice pressure along the center. I used Gorilla Type 2 water-resistant wood glue to secure these pieces onto the latex. Now this gunnel strip is about 5/8 of an inch wide, and the railing strip is about 7/16 wide, and they're both 3/32 basswood. You'd think that if you cut them in a straight line that you could bend them into shape, but it just can't be done. The basswood is just too stiff and strong. To get the right shape of these pieces, I set basswood up against the shear line, marked it with a pencil, and then cut it with a knife. And then I used this handy tool that I've used so many times in my builds. I would then put a mark along that curve and draw a line. And then I can cut this line out and I get the proper shape here for the gunnel and the railing. Now you should really consider making one of these if you're going to do any model work. What this is a standard compass. You can get them from the dollar store. All you have to do is make a small shaft collar right here, something that you can screw down tight. The collar rests up against your wood or paper, and then you can easily draw a line. And I have made so many parts for these models using this simple device. So make one of these. You can do it for probably $1. And starting right about here, I used basswood on the end grain to get it around that curve. Same method I've used on the other builds. Now this model steamer is not being built according to an official plan. I base all of my decisions and designs on images that I see from searches and so on the internet. So it'll be an approximation of a supply steamer. And that's why I like to get the water line on here as soon as possible before I do any work above the railing. And the way I did that was on the same as the gaff pilot cutter build. I marked the water line first, and then I placed tape on the lower edge of the water line. Then I put on 2 coats of latex primer sealer, and that formed a lip up against the tape. When I pull the tape off, I could follow along with a small thin brush right up against that lip, and then it was easy to paint on the rest of the paint with a wider brush. The rudder shoe, the rudder, the propeller shaft has all been installed at this point. I've covered this in great detail in the bad weather ship build. The rudder has a 3mm shaft that has been scored and epoxied in. Each side of this rudder is 3/32 basswood. The rudder shoe is constructed of chain link fence reinforcing rod. The keel has been notched out to let this end here in, and it has been epoxied. The standard 42mm nylon prop. This is a left-hand prop. The prop is secured with a 3mm right-hand nut. There's a brass shaft dog here with 2 set screws that is secured into grooves on the shaft using Loctite, so it won't move. And at this stage in the build, everything is fully operational. All fully proportional, everything is adjustable. And looking inside the boat, here's the servo and the rudder servo arm. And we have forward and reverse. I've installed a 3-position motor mount and epoxied it on both sides directly onto the gel coat. I'm going to be using a single motor on this old supply steamer, but I've made provision for a cutout here, port and starboard, if I did ever decide to go with a 2-motor arrangement. The motor mount is made of 1.5-inch aluminum angle, 1/8 of an inch thick. The motor is a 12-volt DC 540 can motor of about 35 turns. I'm using a stainless steel universal coupling available off eBay. One hole is 1/8 of an inch for the motor shaft, and the other hole is 3mm for my propeller shaft. I've replaced the 2 set screws that come with this unit with 2 3mm machine bolts, and they screw down onto 2 flats that I've filed into the ends of both shafts. The propeller shaft tube is 5/16 OD brass tubing available from a hobby store. There is a 2.5mm lubrication hole here that fits the end of my lube gun. At the upper and lower end of the shaft tubes, here and on the rudder, is a sealed roller bearing. These are available off eBay. I epoxy those into the ends of the shaft tubes. And I have a small cover made of heater hose that fits over the loophole. I've also installed an intermediate shaft tube support piece, and that is epoxied onto the tube and the hull. That should cut down on any possible vibration. Port and starboard are the 2 battery beds, and they are epoxied directly onto the hull. I plan to use 7.2-volt batteries, but they are long enough to accommodate an 8.4-volt. I usually install 2 batteries, 1 port, 1 starboard, in my models. Now, that helps me to balance the boat out, and it gives me a little bit of extra power if I'm out for a long run on a beautiful afternoon. I have an electronic pod box, and this box can be lifted out and put into other models. So I make sure that I have a proper holder for this box in each build. Now, the box is just a tight fit for the electronic speed control. This one has a fan, and it will run 1 or 2 DC motors. There's an on-off switch here, and there is the Dumbo receiver. And it just fits in here like that. And I don't know how well you can see it, but here I have the servo bulkhead, and I've epoxied that onto the hull and also incorporated the electronic pod box holder into that structure so that it should be plenty strong. And behind the bulkhead here, I have two pieces of wood coming out. Looks like about 1/2 inch square, and I'm using that as my servo mount. It has all been glued in place and it's fairly rigid. I'm using an MG996R servo on this boat, and I use the same servo arms that come with the servo kit. These are available off eBay and are fairly inexpensive. I've used a piece of brass coupling here and drilled out the plastic servo arm that came with the servo and CA glued that in place. I've also grooved the shaft so that these two tightening bolts have a good firm surface to clamp down on. And looking at the rudder shaft tube from this direction, I also have a lubrication hole right here that I can get at when I reach through the hatch with my lube gun. And it also has a lube cover. So now we have all our electronics and shafting connected. Everything is tuned and ready to run. The next step on this build is going to be to fix uprights all the way along the sides here of the hull and fix the deck in place and fill in this section here with basswood. Now that's going to create a lot of dust. There'll be shavings inside, bits of filler and so on, and I don't want to damage or mess up any of my electronics and so on. So what we're going to do now is disassemble all the parts inside, and this is where it really pays off to make everything removable. The first step is going to be to remove the rudder shoe. These are 3mm nuts and bolts. And the rudder shoe will just swivel like this and drop down. Next, we're going to loosen off the screws that hold the servo onto the rudder shaft. And now the rudder will just drop out. Next, we loosen off the universal joint at the shaft and at the motor. And now the shaft assembly can be drawn out of the tube. The universal will just slip off the end of the motor shaft. I'll disconnect the DC motor from the electronic speed control. And I'll loosen off the two 3mm bolts that hold the motor onto the motor mount. And I'll place these little bolts back into the motor so I don't lose them. Next, remove any batteries that are in the boat. Disconnect the servo lead that's located in spot number 1 on the Dumbo receiver and lift out the electronics pod. Just leave the rudder shaft servo and the servo link arm in position because it's already been set. Unscrew the servo from your servo bracket. Gently swivel the servo so that you can get your screwdriver in. Lift the servo up and then work it out of the bracket. Put some masking tape over the rudder shaft tube hole. That'll keep the dust out. And do the same on the propeller shaft tube hole. So that just took a few minutes, and working through the hatches in the future, I should be able to blow most of the dust down into the forward area here where I can easily scoop it up with a damp rag. And don't forget to cover the exterior shaft tube hole with some masking tape and the rudder shaft tube hole. And here are the basic components that run the boat. I've painted the white nylon prop with a slate-colored Testors oil-based paint, and that stuff is on there pretty good. It doesn't wear much, even with numerous runs of the boat in sand. The rudder's fairly aerodynamic, and at the top end of the rudder and the bottom end, I've got a washer, and that minimizes wear and contact when the rudder's turning. I just CA glued them onto the wood. I thought that at this stage in the build, I might take a closer look at this pod box and the transmitter and receiver, because when I first started in radio control, I knew nothing about the actual electronics, and still am not an expert at it. But I had plenty of sort of hands-on woodworking experience, that type of thing. But this was a mystery. So I'm just going to get into this a little bit more next. So this is an electronic speed control. And this is what you would receive in a package from China usually, if you ordered it off eBay. From a novice point of view, we really just have to know what these connectors do. That's a Tamiya fitting, and the standard 7.2 volt battery will connect here. This is an on-off switch. Now there's 4 other wires here that I have connected together. The one marked X will operate just a single DC motor, and that's what I had in the steamer model. If I would have had 2 motors mounted, this other one here, black and a red, would connect to the other motor. And everything works the same. It's just that there is a 2 motor with the RPMs instead of 1. And this wire connects to the receiver. It's a female plug. They're all standard. And if you order your Dumbo 6-channel transmitter and receiver off eBay, as I did, receive these 2 items in a box and a lot of instructions. The receiver has a wire coming out of it, and that is the antenna. And you can see there's a number of rows, and they're numbered 1 to 6. And there's an expression in the RC car hobby that 1 to turn, 2 to burn. The electronic speed control connects to the number 2 position with the black wire facing out. 1 to turn, that could be a rudder or a steering wheel. The servo connects here with the brown wire facing out. And those are the only 2 channels we use. And there are 4 other channels available. So the signals are sent from the transmitter. The transmitter has the steering wheel here, 1 to turn. The number 2 position is the throttle, forward and reverse. Number 3 channel is activated by a button here. Number 4 is activated by a switch here. Number 5 is activated by a dial on the top. And number 6, a dial on the top. So our steamboat model is using channel 1 and channel 2. And my sailing models had the sail servo activated by connecting to number 6. But there's all kinds of other options available to someone who wanted to use these other channels. And when you lift the lid on your transmitter, you'll see here that there are controls for channel number 1. This is the steering. And on the right are the controls for the RPMs. And from my experience, if you do not connect this correctly, it just doesn't work. It doesn't burn anything out. And that was something that I was really worried about when I first got into this. So there's a little heads up. So anybody who's thinking about getting into radio control workboats, don't let the technology hold you back. It's really easy. So that brings us to the end of part 2. Hopefully there were some details in there that will help along the hobbyist, especially people who are new to radio control. In part 3, we're going to be working on the deck structure. It's going to be fun building it up and making it look like a real 1898 supply steamer. Thanks for watching.